The next type of simple machine we want to look at is the pulley. Pulley is a lever consisting of a wheel with a groove in its rim that's used to change the direction and magnitude of a force exerted by a rope or cable. So pulley IMA. So when we're looking at the pulley IMA, a first class lever is a fixed pulley because you've got the fulcrum that's in the middle and you've got a force and you've got a force that are both kind of pulling in that same direction. So the first class lever with an IMA of 1 is what a fixed pulley is. Whenever we've got a movable pulley, well, we've got a fulcrum that's here. Then we've got a force that's being applied to that end of that pulley, and then we've got a force of effort that's taken to pull that one back up. So when the resistance and the effort are set up the way they are, you've got a second class lever, which means that your IMA then is 2, or more importantly, it's greater than 1, so it takes less effort to pull that resistance that's there. When we put pulleys in combination, pretty much we're looking at the number of strands opposing the force of that load. So we have this system on the right where there's one rope that's being threaded through all of those different pulleys that are there. So what's the IMA of that pulley on the right? IMA is 4, because the number of strands opposing the force of the load. So there's 1, 2, 3, 4 that are pulling up. This one's pulling down. That's there. So we have 4 different forces that are applying and going to that load. So that was pulleys. More importantly, it's kind of looking at that fixed one. IMA is 1. We got movable 2. We can start putting those in combination and building compound machines. So we've got a compound machine here where we're looking at, we've got a pulley that is then pulling up this lever that has the resistance that's sitting there. So how much force effort put in here must be needed to overcome that force of resistance that's there, giving all of these different distances and such? Well, the IMA total is equal to the pulley IMA times the lever IMA. So the pulley IMA has 2 strands that are opposing that force, so it's got a IMA of 2, and then we look at the IMA of that lever, IMA always being distances. We have the distance, we have 12 divided by 4, so therefore the IMA total is 6. So it takes 6 times less effort to lift this here than that. So 1 pound of force here would be able to lift 6 pounds of resistance force there. What happens if we put pulleys into combination? If we put pulleys in combination, when we want to look at that IMA of that whole system, well, we have 1 pulley, 2 pulley, 3 pulley, and what we're going to do is we're going to take and calculate that IMA total by multiplying all of those together. This right here is 2 times 2 times 2. So the total IMA, fixed pulley, fixed pulley, fixed pulley, is that 8. So therefore, what does that mean? It takes only 10 pounds of force here to lift, to pull up that 80 there. If this was 1 pound of force, we could lift 8 pounds of force. This is 20, we could do 160. If this was 15, that would be 120. That's there. Pulley AMA. AMA is still the same way as we're going through. If we're given 2 forces, we divide the 2 of them, we can calculate that. We have resistance, we have effort, we have 80 over 23, reduces down to an actual mechanical advantage of 3.48. So the actual mechanical advantage 3.48. What was the ideal mechanical advantage? Well, the ideal mechanical advantage is 1, 2, 3, 4 strands that are opposing that. So we take that 3.48 divided by that 4. We get an efficiency of 87%. So that one pulley has an efficiency of 85% working for it. Common misconceptions: angles don't matter. They do. We will talk about these force vectors and stuff when we get into the second semester, but that requires a trig, which in our geometry class we're not ready to do that yet. So we're looking at that fixed pulley. We're going to just assume right now that it's got perpendicular distances, and we're going to go with an IMA of 2. Also, when we're looking at it, we count the effort strand if it's pulled up. No, we're looking at those opposes. So this strand right here and this strand right here oppose that force. They're going the opposite direction of that force. So therefore that IMA is 2. So if it's going up, these two forces are pulling down. We got that IMA of 2 itself. So that concludes our pulleys. Not the best examples of stuff, but just kind of think of that. Think of your IMA, think of your AMA. If you've got two forces, you're thinking of that AMA to be able to divide and work with.